and then you can have a view of all the position of the motors over the period of recording. So this one is a little bit confused because we have all the motors in here, so we can focus on one arm, let's say the right arm. Yeah. So this is the position of just well, this is the position of all the joints of the arm. This is just the shoulder. And well, if we activate the robot, we can actually tune. So the robot is going into the position of the time frame, and we can move. Well, this one is not convenient, but we can fine-tune the position of the robot. So this is actually how we record the dances we use for the dancing activity. You can also, sorry, just one. You can also tune the acceleration of the movement using Bézier curves like that.
Yeah, I can imagine that certain positions of the joints are not possible.
Yes, it's
in comparison to other positions of other.
Thank you. It's a good question. It's actually limited, so you cannot go over certain positions. So you see here it's limited to 120 positive and 120 negative, and other joints will be limited to more.
So the position of other joints will be sort of.
There can be interaction. Yeah, it's a difficulty to operate the robot so that it does not. Yeah, let's say cross arms or. Yes. So again, so I'm not going to talk about the next version of robot, but the next version of NAOKey, I explain that we are using the operating system or the framework called NAOKey. The next version that is going to be released in a week will provide the robot of self-awareness of his body. So, for instance, when you ask the robot today, if you ask the robot to go from this position, from this position to this position, he will try to go through his torso, because actually the interpolation of between the points, between the position we have recorded, is made automatically by the robot. So he will try to go to the shortest way, and so this version will damage probably the shoulder and the elbow. The next release will have self-awareness of his body for the arms, and he will go above the torso, and he will not hurt anymore any part of his body with all the arms, so including the hip, because when he's walking, he can actually damage himself through the hip. Yeah.
And how does it work with vision? Can it track like a red ball?
Yes.
Is it difficult to program that with the vision?
Okay.
Well, I don't have to track something, but I just wanted to know, is it as easy as it is, or is it like...
So there, for ball tracking, there is a box. So we have already designed a behavior of ball tracking. It's part of the commercial presentation, so I can show you quite easily. And then I have, I don't know if everybody is interested by this question, sorry, but this element. But I have also a demonstration of how you can integrate OpenCV programming. Are you familiar with OpenCV or not? Okay. OpenCV is, as far as I understand, it's a language used for programming vision, and so it's you can include OpenCV in your programming if you are used to, for enhancing the vision capacity of the robot. So, does that respond to your question? Or?